So this question was asked in GATE 2016 Electronics and Communication Engineering paper set 2, in which an op-amp has a finite open loop voltage gain of 100 and the input offset voltage as 5 millivolt is modeled by this circuit. Also, you have given the amplifier is ideal in all other respects. So if you have given the input voltage as 25 millivolt, then you need to find out the output voltage in millivolt. So the NPTEL reference for this question is Basic Electronics by Professor Chitralekha Mahanta, Department of Electronics and Communication Engineering, IIT Guwahati. You can find reference in the Module 4, Lecture 6, which is the practical op-amp. So the useful data for this question is, if you have given a op-amp whose non-inverting terminal voltage as V plus and inverting terminal voltage as V minus, and the output as V0. And if you have given this op-amp has open loop gain as AOL, then you can write V0 equal to AOL times V plus minus V minus. So for an ideal op-amp, your V plus is equal to V minus, that is the voltage as the non-inverting terminal is equal to the voltage at the inverting terminal. So your open loop gain for an ideal op-amp is infinite. Now, this is the first useful data for this question. Now, if you use this op-amp to design a non-inverting amplifier, which is shown in this figure, that is, so this is your inverting terminal and this is your non-inverting terminal. You apply the voltage at the non-inverting terminal for an non-inverting amplifier, and this is your resistance R1, and this is your feedback resistance R2, and this is your output V0. This is your ground terminal. So for this amplifier circuit, the op-amp has open loop gain as AOL. The gain of this circuit will be given by V0 over Vi is equal to 1 plus R2 over R1 upon 1 plus 1 over AOL times 1 plus R2 over R1. Now, the third useful data for this question is that in the case of an ideal op-amp, the voltage at the non-inverting terminal is equal to the inverting terminal. So if you have this op-amp whose non-inverting terminal voltage is V plus and inverting terminal voltage is V minus, then these two voltages will be equal for an ideal op-amp. However, there are difference in the input impedance and the input bias current between these terminals. So your input bias current of this terminal IB plus is not equal to the input bias current of this inverting terminal. So due to this, there is a slight difference between the voltages of these inverting and non-inverting terminal, and this V plus is not equal to V minus. And the difference between this voltage V plus minus V minus is defined as the input offset voltage. Input offset voltage. So which multiplied with the gain of the op-amp to give the output due to offset voltage along with your input voltage. So that is, if you have an op-amp is designed as the non-inverting amplifier, and this is your input offset voltage, and this is your input, and this is your feedback configuration, this is your R1, and this is your R2 as a feedback resistance, then your output contains, this is your input voltage VA, so your output contain the output due to VO input bias voltage plus output due to your input voltage. Now, coming to the solution, in the question you have given the R1 as 1 kilo ohm and your R2 as 15 kilo ohm, and this is connected in the configuration of non-inverting amplifier with input bias voltage as 5 millivolt and the input voltage as 25 millivolt. So this you have given in the question. So you need to find out the what is the output voltage. Also you have given the open loop gain of this op amp as 100. So you need to find out the value of V0 in millivolt. So you can write the gain of this non-inverting amplifier as V0 upon Vi dash, where Vi dash containing the two voltages, one is your input and one is your input offset voltage, and this will be equal to the 1 plus R2 over R1 upon 1 plus 1 over AOL, where AOL is the open loop gain of this op amp, and 1 plus R2 over R1. So you can put Vi prime equal to 5 millivolt plus 25 millivolt, which is equal to 30 millivolt, and R2 as 15 kilo ohm and R1 as 1 kilo ohm. Then you will get V0 equal to 1 plus 15k upon 1k over 1 plus 1 over 100 into 1 plus 15k over 1k into 30 millivolt. So after solving this, you will get V0 as 413.79 millivolt. So the correct answer for this question is 413.79.